it's Jacob here. We're starting a question of the day series for the SAT and the ACT to replace the question of the day that many of you guys got in school. So today we're starting with SAT Math, question 11 on test 3, no calculator. And we've got an angle question here, almost very similar to a lot of ACT questions you'd see. And we're not given much. We know that these intersect at a point, that's obvious. We know that this equation is true. So we're asked what must, that must is going to be key, must be true. So x plus y is equal to u plus w. I can mark that up if I want, but I might just hold off on that right now and mark my vertical angles first. Either way would be fine. I'm going to mark my vertical angles because it's the only other piece of information I have, and I'm probably going to need it because this alone does not look like enough to solve. So I know that w and z are equal. I know that y and u are equal. Oops. And I know that t and x are equal. So I've got 3 pairs of angles, as I should, right? Now, there's nothing else I can do with this. I have no measures. I have no additional angles. I'm kind of stuck where I'm at. So I'm going to have to go back to this equation. So they gave me x plus y is equal to u plus w, okay? Well, on the surface that doesn't do a lot, so x is a 3, y is a 2, u is a w is a 1, I'm talking about the number of bars I used to mark the vertical angles, and u is a 2. Okay, there we go. Y and u, right there, vertical angles to each other. So I could say that y is equal to u, right? And if you really want to be fancy, you can substitute in here, right, and say x plus y is equal to y plus u, or you could use, y plus w, or you could do the same thing with u if you liked. But the end result is that these two are going to cancel each other out, and you're going to end up with x is equal to w. So going back to my diagram, x is a 3, w is a 1. Well, let's just say w is a 3. It's easier than erasing. And if w is a 3, that means z is a 3. So now I know that I have four angles that are 3s, and then y and u are still 2s. So x plus z, or x is equal to z. Yeah, that works. They're both 3s, right? So I'm going to get rid of any answer choice that does not include number 1 as an answer. So that gets rid of letter C. Number 2, y is equal to w. Well, w is a 3, y is a 2. That doesn't work. Now, it could be, and I think it's very likely if you actually measured it out with a compass or something, that w and y are equal to each other. But we can't prove it. So it's not what we know or what we believe, it's what we can prove, and I cannot prove that. So I'm going to say 2 is out, and anything that has 2 in it, therefore, is also out. That gets rid of A, and that gets rid of D. And as is often the case with these Roman numeral Markov questions, I don't even have to do all 3 parts to know it's B. I would go ahead just for fun and confidence sake to check the last one here, check Roman numeral 3. Z equals T, Z's got 3, T's got 3. 1 and 3 is our correct answer. So I hope that was helpful. My intent is to make videos alternating between the SAT and the ACT on a daily basis. I'm going to pick problems that are, 1, concepts you guys tend to have difficulty with, and 2, problems that transport well from across tests. So while the content on the SAT and the ACT is virtually identical, the presentation is different. So at least initially I'm going to pick problems that you could just as easily see on the ACT as you would the SAT and vice versa. Thank you, good luck, and have a great day.